Hello everyone and welcome to this video on logarithms. In this video we'll understand the basic working principle behind logarithm as to why do we need to use logarithm. Then we'll see some properties of logarithm including the base change rule, product rule and division rule. Then we'll understand what is characteristics and what is mantissa and see how it is going to help us in finding the number of digits in a number. So let us begin. Now if I give you two pair of numbers, let's say 2 and 8. And if I ask you how many times do you need to multiply 2 with itself to get the value 8? So the answer is simple. You have to multiply 2 with itself 3 times. That is, you'll have to cube it. So 2 cube will give us 8. Now if I give you another number, let's say 27 and 3. If I ask you how many times do you need to multiply 3 with itself to get the value as 27? Again, you have to multiply 3 with itself 3 times. So you will have to cube it. So 3 cube will give us 27. Let's take another pair of numbers, 36 and 6. So how many times do you need to multiply 6 with itself to get the value as 36? You will have to square it. That is, you have to multiply 6 with itself 2 times. Similarly, if I give you this pair of numbers, 110. So how many times do you need to multiply 10 with itself to get the value as 100? Again, 2 times. So you'll have to square it. Now, if I give you this number, 2 and 10, and I ask you the same question, that how many times do you need to multiply 10 with itself to get the value as 2? Now, this is not a straightforward answer. For each of the previous 3 cases, we could have either squared it or cubed it or raised to some integer power by which you would have got your answer. But in this case, since 2 is less than 10, so we'll have to raise it to some decimal power. Let's say b. We don't know. In this case, it was quite simple for us to understand. But in this case, it is not direct. In situations like these, logarithms comes handy. So we will make use of logarithms to find the value of b. So as you can see, all these numbers that we have taken, they are of the form of a raised to b equal to c. So you have to multiply a with itself b times to get the answer as c. So in this case also we need to find how many times do we need to multiply 10 with itself to get the answer as 2. So what we will do is, since all these numbers are of the form of a raised to b equal to c, we will take log to the base a on both the side. So this will become log to the base a of a raised to b equal to log to the base a of c. Now by using one of the property of logarithm, that is log a raised to n to the base a is equal to n. So by using this property, this left hand side, it will become equal to b. So b will be equal to log c to the base a. So in order to find the value of b, we'll have to make use of log c to the base a. So c in this case is 2 and a in this case is 10. So b will be equal to log 2 to the base 10. So by finding the value of log 2 to the base 10, we'll get the answer for b. That is, how many times do we need to multiply 10 with itself to get the value 2. Now for log to the base 10, there are some standard values which are available. Log 2 to the base 10 is equal to 0.3010. That means you need to multiply 10 with itself 0.3010 times to get the answer as 2. So if you raise 10 to the power 0.3010, you will get the answer as 2. You can check this thing in the calculator. So this is where logarithms comes in handy, where it is not possible to directly identify what will be the value of b or to what power the number or the base has to be raised in order to get a certain value. This format, a raised to b equal to c, is called the exponential format. And this format, b equal to log c to the base a, is called the logarithm format. So the relation between these two is a raised to b equal to c is b equal to log c to the base a. Let us now discuss some properties of logarithm. Before that, let us understand the two widely used type of logarithms. One is the natural logarithm. In natural logarithm, the base is e, where e is 2.71828. So whenever you see the base to be equal to e, then such a logarithm is called natural logarithm. Natural logarithm is also expressed as ln, whereas the other type of logarithm that is widely used is the common logarithm. In common log, the base is 10. So wherever you see the base as 10, then that logarithm is known as common logarithm. In question, sometimes it is possible that the base is not given. It will be simply given as log of 278 or some number, and the base will be missing. So in such cases, you will have to assume the base as 10. We'll have to assume it to be a common logarithm and solve the problem. Let us now discuss some properties of logarithm. So log c to the base a equal to b. This is what we have derived. How many times do we need to multiply a with itself to get the answer as c? It is b times. Now there are certain restrictions on this formula. The base can never be negative, and the value of c also can never be negative. So logarithm of a negative number and logarithm of a negative base is not defined. So both a and c has to be positive numbers. That is, they have to be greater than 0. Now let's see the second property of logarithm. Log a to the base a, that is log of a number to the same base, will always be equal to 1. In this case also, a has to be greater than 0. Also, a cannot be equal to 1. It is not defined for a equal to 1. So it is very simple to remember this. How many times do we need to multiply a with itself to get the answer as a? It is 1 times. The third property, log of 1 to the base a, where a is any base, is always equal to 0. Again, a cannot be negative, hence a has to be greater than 0, and a cannot be equal to 1. So log of 1 to any base is always going to be equal to 0, where the base can be anything, but it has to be positive and not equal to 1. So this is one group of property that you need to remember. Let us now move to the next group of property. Log of b raised to n to the base a will be equal to n times log of b to the base a. So whatever number is there in the power, you can take it in front of the log and multiply it. So log b raised to n to the base a will be equal to n times log b to the base a. On the similar lines, the next property, log a raised to n to the base a will be equal to n, because this n we can take in the front. This will become n into log a to the base a. Now log a to the base a, as per the first property that we have seen, will be equal to 1. So we'll have n into 1, which will give us the answer as n. Let's see the next property. A raised to log n to the base a will be equal to n. So if we have a number which is raised to a logarithm having the same base a, so the base and the log value will cancel out, we'll be left with the number itself. So if we have an expression which is of the form of a raised to log n to the base a, its value will be equal to n. So again, the value of a can be anything which is positive, but it cannot be equal to 1. So if we have an expression of the form of 10 raised to log 10 to the base n, the answer will come out to be n. If we have an expression which is of the form of 49 raised to log n to the base 49, the answer will still come out to be equal to n. So these are the properties which will help you in simplifying and solving the problems based on logarithms. Let us now see the product and the division rule. So if we have log of product of two numbers, let's say a and b, to any base c, so this can be split up and written as log a to the base c plus log b to the base c. So if we have a logarithm of product of two numbers, it can be split up as log a to the base c plus log b to the base c. So this will be the common base. Similarly, the division rule, if we have log of division of two numbers, let's say a by b. Now if I do not mention any base, you will have to assume the base as to be 10. So this will be written as log of a to the base 10 minus log of b to the base 10. So logarithm of division of two numbers can be split up as log a to the base 10 minus log b to the base 10. The base can be anything. If it is not specified, we'll have to take the base as 10. So for product, we'll use the plus sign. For division, we'll use the minus sign. Now do not confuse this formula with log a to the base c into log b to the base c. This cannot be written as log of a plus b to the base c. No, it is not possible. There is only one version of this formula. That is, log of product of two numbers can be split up into log a plus log b, whereas two separate product of logarithms cannot be added up. Do not confuse between these two rules. This is the only valid rule. This is the invalid rule. It is not applicable. But in case of division, there is another rule which you can use, which is the change of base rule. So if you have ratio of two logarithms, log a to the base c upon log b to the base c, this can be written as log a to the base b. So in case of division, you can use this rule. You can take the division of two numbers and split it up as log a minus log b, and you can take the division of log and write it in this way. But remember one thing, the base should be common. So if the numerator has a base c, the denominator should also have the same base. So log a to the base c upon log b to the base c can be written as log a to the base b. This will be helpful in solving a lot of problems. You can go the other way around also. So if you have a logarithmic expression which is of the form of log a to the base b, then this can be written in some other base. We can change the base to, let's say, some other base c. We can write this as log a to the base c upon log b to the base c. So this is basically your change of base rule, and this will be helpful in solving a lot of problems. Let us take one example and understand how to apply this concept of change of base. Let's say if you want to find the value of log 64 to the base 16. So how are we going to use this? So if you notice, this number 64 is nothing but 4 cube, and this number 16 is nothing but 4 square. So they both are power of 4. So we can split this logarithm into a logarithm of base 4. So we can write the numerator as log 4 cube to the base 4 divided by log 16 can be written as 4 square. So this will be 4 square to the base 4. By using the change of base rule, we can do this. Now this can be written as, by using the property of logarithm, that is log a raised to n to the base b is equal to n times log a to the base b. So this will become 3 into 4 times log 4 to the base 4, and the denominator will become 2 times log 4 to the base 4. Now log 4 to the base 4 is equal to 1 because log a to the base a will be equal to 1. Similarly, this will also become equal to 1. So we will be left with 3 by 2, which is 1.5. So in this way, by applying the concept of change of base, you can easily solve such problems. Let us now see one of the most important property which will be really helpful in solving problems on logarithms. If you have an expression which is of the form of log of a raised to m to the base b raised to n, then this can be written as m upon n into log of a to the base b. So you can take these powers out. This power will go in the multiplication part, and the power of the base will go in the division. So this will be written as m by n into log a to the base b. If we take the above example itself, log 64 to the base 16, let us see how we can solve this problem faster. So log 64 to the base 16, as I have said previously, this is 4 cube and this is 4 square. So this expression will become log of 4 cube to the base 4 square. So the value of m is 3 here and the value of n is 2 here. So this can be written as, by using this expression directly, it will become 3 by 2, taking m in the numerator and 2 in the denominator. So this will become 3 by 2 into log 4 to the base 4. So log 4 to the base 4 is directly 1. This will become 3 by 2, which is equal to 1. So in this way, you can use this property for solving different types of problems. Both these properties are very useful. They will help you in solving a lot of problems. Now coming back to our original equation of logarithm. So we had log c to the base a equal to b. Now the value of c, as we have discussed, has to be greater than 0. Log of negative number is not defined. And if this value of c is less than 1, it is greater than 0 and less than 1, then b will be negative. That means log of any number between 0 and 1 will be negative. And if this value of c is greater than 1, then the value of b will be positive. That means log of any number greater than 1 will be positive value. Let us now move ahead and understand the concepts of characteristics and mantissa. Let us take an example. Let's say log of 256. Now log of 256 I have not mentioned any base, so we'll have to assume the base as 10. So log of 256 to the base 10, its value is 2.4082. So as you can see, the value of any logarithm will consist of two parts, the integer part and the decimal part. This integer part is called as characteristics of the logarithm. So this is the characteristic. The integer part is called the characteristic. And the decimal part of the logarithm, this is called the mantissa. Now one important property regarding mantissa is that the mantissa of a logarithm can never be negative. It has to be always positive. It can never be negative. Now what happens if the mantissa becomes negative? So we'll have to convert it into positive. Let us see how it is to be done. Let us take this example, log of 0.00. Since this value is less than 1, so the log of this number will be a negative number. And log of 0.002 to the base 10 is minus 2.6989. So as you can see here, now this value is coming out to be negative. It can be split up and written as minus 2 minus 0.6989. So as you can see, this is your integer or the characteristic part, and this is your decimal or the mantissa part. Now the mantissa is negative. We'll have to make it positive. So to make this positive, since this is a decimal part and it is always going to be less than 1, we'll add 1 to it and make it positive. Since we have added 1, we'll have to subtract 1 to balance the equation. So we'll subtract 1 from the characteristic part. So now this will become minus 2 minus 1 will become minus 3, and minus 0.6989 plus 1 will become plus 0.3011. So now your mantissa has become positive. So remember, your mantissa should always be positive. It can never be negative. If it is negative, you will have to convert it into positive term. Now this expression can further be written as 3.3011 with a bar over the characteristic. So this bar indicates that the log value is negative. So in this way, you can express the log of any value. Either you can express it as minus 2.6989, or you can express it in this format by using the bar. Let us now understand two more important concepts which will help you in solving the numericals. Now log of any value, let's say x, is always of the form of n point a, b, c, d, e. It will have an integer part and it will have some decimal part. So if you know the log value of any number x, which is equal to n dot a, b, c, d, e, then you can easily find what will be the number of digits in this value x. It will always be n plus 1 digit number. That means this number x will consist of n plus 1 digit before the decimal part. We'll see how to apply this concept. Let's take the second property. If the value of x is between 0 and 1, then the log value will come out to be negative. It will be of the form of minus n dot a, b, c, d, e. It will be negative value. So in this case, you can find out what will be the number of zeros after the decimal. Since the value of x is between 0 and 1, if you want to find out the number of zeros after the decimal, it will be simply n. And if you are expressing this negative logarithm in the bar format, it will be n bar dot a, b, c, d, e. So the number of zeros after the decimal point, it will be n minus 1. Let us take the two examples that we have taken above. For this case, as we can see, the log of 256 is 2.408. So the number of digits in this number 256 is 2 plus 1, 1 more than the characteristic of this logarithm. It is 3 numbers. And if we take the second example, in this the value of x is between 0 and 1. As you can see, the log value came out to be negative. It is minus 2.6989. So the number of zeros after the decimal point is 2, which is same as the value of characteristic. And if we are expressing this value in the bar format, then the number of zeros after the decimal will be given by n minus 1, which will be 1 less than the characteristics. So in this way, you can find the number of digits in a number if you know the log value, and you can find the number of zeros after the decimal point in case of negative logarithm. Let us see how to apply this concept in finding the number of digits. Let us take this example. If you want to find the number of digits in 16 raised to 16, now this is a big number. It is not possible for us to calculate the value and then count the number of digits. So what we will do is we will take the help of logarithm. So we'll find the log value of this number. So we'll find the log of 16 raised to 16. As I have mentioned previously, if the base is not specified, always consider it to be a common logarithm. The base has to be 10. So we'll find the log value of this. Once we have the log value, we'll use this principle that the number of digits in x will be 1 more than the characteristic. So let's see how it is to be solved. Now 16 can be written as 2 raised to 4. So this will become log of 2 raised to 4, the whole raised to 16, and the base is 10. This can be further written as log of 2 raised to 16 into 4 to the base 10. Now this power 16 into 4 can be taken in front of log. It will become 16 into 4 is 64. 64 into log 2 to the base 10. Now the value of log 2 to the base 10, it is a standard value which we'll have to remember, which is 0.3010. So we'll get 64 into 0.3010. So if you multiply this, we'll get 640. 64 into 3 is 192. So we'll have 2. Then 19 carried. It will become 19.2640. So the log of 16 raised to 16 is coming out to be 19.2640. That means this number 16 raised to 16 will have 19 plus 1, that is 20 digits. Hence this number 16 raised to 16 is a 20 digit number. In this way you can find the number of digits by using these properties. So if you remember all these properties which I have explained you in this video, you will be easily able to solve any problems based on logarithms. So in the next video, we'll solve some more problems based on logarithms, which will help you in getting a better understanding of all these properties. So this is all for this video. Thank you.